So in this video, we want to talk about the standard form for the equation of a hyperbola with center h, k. So there's two different types. So the first one, the foci and the vertices are on a horizontal line for this first one. And that will look like this: x minus h, the quantity squared, over a squared minus, notice the minus, the ellipse has a plus there, here we have a minus, the quantity y minus k squared over b squared equals 1. There's always that 1 on the right side with these and ellipses and circles. Well, not circles, we have an r squared there, just these and the ellipses. Okay, the second type, the foci and vertices are on a vertical line. That's the second one I had on the previous page, I believe. Yeah. And this is y minus k squared over a squared minus x minus h squared over b squared. So what has happened here is I just switched the x minus h and the y minus k. So now the term with the y in it is positive, and the term with the x in it is negative. For the first one, the term with the x in it is positive, and the term with the y in it is negative. Notice that the a, which gives you the distance from the center to the vertices, the a here is always on the first one. Now other books will do this differently. They'll use the a. They'll have like the a always with the x's or something, like they do with like we do with the ellipses. But for the hyperbolas, we are going to use the a squared. The a will always give us the distance to the vertex from the center, and so it's always going to be with the positive one, the first term here. So the b will be the second term. So the b is in the x direction. The a is in the y direction here. Up here, the a is in the x direction and the b is in the y direction. Okay? So I just made a note of some of this stuff. A is the distance from the center to the vertex along the line through the foci. Right? Oh, the center, the foci, and the vertices are all in the same line. Now we have this formula, c equals square root of a squared plus b squared. This looks just like the Pythagorean theorem, c squared equals a squared plus b squared. Remember, for ellipses, a was always the larger number, larger than b, and we had c equals the square root of a squared minus b squared. So for the hyperbola, it's a squared plus b squared. This is equal to the distance from the center to the foci along the lines through the vertices. Okay, so A is the distance from the center to the vertices, to each of the vertices, and C is the distance from the center to each of the foci. So for this, the C will be larger than the A. Hence the plus inside the square root. So this is just to compare. For ellipse, you subtract those two, and that makes C smaller than A. The distance to C is smaller from the center. The distance to C from the center is, for the ellipse, is smaller than the distance from the center to the vertex. So C is smaller than A. For the hyperbola, C is larger than A. So that's why one is minus and one's plus, or at least that's a way to remember it. For the ellipse, A is always the larger number. For the hyperbola, A could be larger or smaller than B. It's just the thing that goes with the positive term. Okay? So the asymptotes are always these: x minus h from here equals a, for this is for type 1, right? x minus h equals plus or minus a over b times y minus k. See that? So compare where those numbers are coming from. So it's like you took away the squares, right? And you made that 0. Really, all you're doing is making this one 0 and solving, and you get this. Because you do the square rule to give you a plus or minus. And that's the equations for the asymptotes. Now the other one, for number 2, you're just going to have y minus k is going to take the place of the x minus h. So you're just switching the x minus h and the y minus k. So you get y minus k equals, but it's still plus or minus a over b. So the distance from the center to the vertex always goes on top, on the right side. Okay, y minus k equals plus or minus a over b times the quantity x minus h. Okay, so that's how you find the asymptotes. A lot of people have trouble finding the asymptotes, not quite sure, but it's pretty straightforward. You're really just putting a 0 here and solving. And if you do that, you'll always get these. Or you could memorize these either way. They're very similar to the equations here. You just have to see, compare and contrast. Compare is find the similarities. Contrast is find the differences. And get that in your head to where you know them.